To make the leap from being the largest bulk handling port in the Middle East region to becoming one of the world's leading bulk ports, Saqr Port in Ras Al Khaimah is about to embark on a project to build one of the world's deepest quay walls in a totally exposed location with no protection from the open sea. The project will enable the acceptance of the world's biggest ships. However, it also means pushing the limits of design engineering in this field of maritime expertise beyond anything that has been attempted before. Ras Al Khaimah is one of the 7 United Arab Emirates. It is the most northerly part of the nation and the closest emirate to the Strait of Hormuz. Its long coastline and geographical features have meant that the people of Ras Al Khaimah have had a special relationship with the sea for millennia. Also situated in the north part of Ras Al Khaimah is one of the world's largest limestone quarries. Quay has been active since the 1960s and has reserves of over 2 billion tons, supplying limestone products, concrete, aggregates and rock armor to massive projects on a global scale. Many of the iconic building projects that symbolize the economic rise of the UAE, including the Burj Khalifa, which is the world's tallest building, and the unique Palm Jumeirah, are constructed from materials originating from Ras Al Khaimah. Indeed, as a non-oil producing emirate, the quarrying and related industrial sectors are the leading contributors to the economy of Ras Al Khaimah. Saqr Port, located near the base of the Quay limestone quarry, has historically been the key distribution point for the export of bulk products from Ras Al Khaimah.
Geography is vital to anything you do. The location of Quay, with great and vast quantity of limestone reserves, and you got great location for the deepwater port. The combination is create a compelling competitive story.
What makes Saqr Port unique is its proximity to the Hajar Mountains. The fact that the raw material has been quarried in these mountains and the transport to get that raw material to the port doesn't cover a great deal of kilometres. Therefore, the port has a competitive advantage.
Name a project you have, a marine project, across the Gulf, you will see it's being supplied by Ras Al Khaimah. Name any prestigious job in the Emirates and some of the neighboring countries, you will see Ras Al Khaimah.
Over time, the demand for such products from the Emirates has increased almost exponentially, from approximately 1.5 million tons at the turn of the century to over 70 million tons in 2018. Even with this massive increase in demand and corresponding efficiency improvements in cargo handling from the Saqr Port management team, the need for products from Ras Al Khaimah to supply the wider construction industry in the Middle East and beyond is so great that ships sometimes have to wait for extended periods to enter the port and collect their cargo. It is against this background that a more radical solution to the supply and demand question was conceived in 2014.
Once it became clear that the existing berth infrastructure at Saqr Port was not going to be sufficient to meet future demand, we started investigating various options to increase capacity. One option would have been simply to add more berths. However, this approach would only allow us to handle more vessels of the same class. From an engineering point of view, we wanted to recommend a more ambitious solution, one which would not only allow us to handle more vessels, but also larger vessels. This in turn meant conceiving a project which would have been bigger and more challenging than anything done at Saqr Port previously, but ultimately one which would significantly raise the bar in terms of the port's ability to handle increased volumes of bulk cargo. The main limiting factor of the port was the depth of the water in the harbour. Therefore, our concept centred around creating more berths outside the existing harbour with an increased water depth.
Saqr Port has a draft of 12.2 metres and contains 8 separate bulk handling berths. The size and scale of the port allows the acceptance of almost all classes and sizes of cargo ships, with the exception of Cape-size vessels. Cape-size vessels are typically above 150,000 deadweight tonnage, and the name is derived from them being too large to pass through the Panama Canal. Thus, vessels of this size must transit around Cape Horn to travel between the Atlantic and Pacific Oceans. Cape-size vessels require a deeper draft and a longer uninterrupted length of quay wall that is currently available at Saqr Port. The addition of 2 new berths capable of accepting Cape-size vessels would increase the annual capacity of Saqr Port from over 70 million tonnes to comfortably in excess of 100 million tonnes, effectively increasing Saqr Port's cargo handling capacity by approximately 50%, making the average turnaround speed of vessels much faster, and potentially opening Saqr Port up to a wider and more diverse range of client vessels from all corners of the globe. A project to build 2 new Cape-size berths would require the construction of a new 700-metre-long quay wall, the dredging of an approach channel, vessel turning circle and berth area seaward of the existing southern breakwater to a depth of 18 metres, and the creation of a reclamation platform between the new quay wall and existing breakwater structures. A project of this scale would require the dredging of approximately 1.3 million cubic metres of material from the seabed, much of which would be utilised in creating the 85,000 square metre land reclamation platform. At its highest point, including the upper section that will sit above the water surface, the new quay wall will reach in excess of 26 metres, making it one of the tallest and deepest quay wall structures in the world. It is estimated that, notwithstanding delays due to weather or other non-controllable factors, that such a project would take up to 2 years to complete. In addition, the exposed location of the project with no surrounding protection from the open sea creates major challenges for the team tasked with delivering the project.
This was always going to be a difficult project to deliver, with a high level of design complexity, the natural challenges faced being directly exposed to the sea, as well as the sheer scale of the project. It was therefore vital to ensure the right calibre of people were engaged in the project from the outset. One critical appointment was that of the project consultant, who would work hand in hand with our own in-house project team. After assessing a variety of consultants, Jacobs were finally chosen to undertake the design and construction supervision for the project.
Jacobs have a long-standing relationship with the government of Ras Al Khaimah, and in particular Saqr Port Authority. We've been involved in the development of Saqr Port historically since the 1970s, and we've been involved in every stage of its development and expansion plans since. Jacobs has been one of the global deliverers of ports and maritime projects around the world. On this project is engaged as the client's engineer. That service involves design of the project, construction supervision of the works, and also the environmental aspects were in our scope as well to deliver.
Whilst the project has obvious operational and commercial benefits for RAK Ports and the Emirate of Ras Al Khaimah, its feasibility from an environmental and engineering standpoint is a crucial consideration, requiring a comprehensive and highly technical survey of the seabed and surrounding marine areas.
Before even starting the project, an enormous amount of work went into confirming the viability and feasibility of the project. We commissioned a metocean and modelling study to determine wind and wave conditions and sea levels. This information was then used as part of a downtime study to assess the frequency of the weather events that could ultimately influence the operational capability of the berths. We commissioned a number of marine boreholes to assess the ground conditions over the project site, and an environmental baseline study was undertaken.
The survey will identify any sensitive, unexpected or unusual features that could otherwise have the potential to make certain elements, or even all, of the project unviable from a construction perspective.
When doing the geotechnical investigation, we found some boreholes with veins of silt. So what we were able to do was to instruct additional boreholes, which gave us some greater certainty about what the founding layer of the quay wall was going to be.
The environmental impact assessment concluded that there would be no major environmental impacts. However, to ensure that the diverse and important marine ecosystem of the coast of Ras Al Khaimah is fully maintained, a 7-week project to translocate coral colonies to a donor site in a different part of the Emirates coastline was implemented. With engineering and environmental feasibility completed, the 1 billion dirham project to build the 2 new berths gets the green light to proceed, receiving approval from His Highness Sheikh Saud. A carefully assembled team, consisting of multiple subject matter experts from around the globe, can now progress full speed ahead with the project design and construction. The exposed location of the new berths, with no protection from the open sea, means that the quay wall has to be designed in a way that enables it to withstand a huge amount of force. In addition, the sheer size and depth of the new quay wall creates a number of extra challenges with regard to developing a suitable wall design.
For the design aspect of the project, we've been involved in the detailed design of one of the world's largest, tallest quay walls for berthing ships against. That involves a hugely complex design analysis. Many quay walls around the world for berthing such ships are within an enclosed, calm port berth area. This wall is an exception to that. It's exposed to storms, exposed to big waves. And in terms of a design, that's been a huge challenge in this project, to actually take all those forces and loadings into account, to come up with a wall design that has its suitable factors of safety and is also an economical design.
The project works start in essence during Q1 of 2017. By this stage, the wall design has been finalised by the engineers and fully approved by the RAK Ports management team, and the tender process to select the main works contractor has been completed. The complex process of mobilising the equipment and manpower required for this massive project must now proceed with a high degree of speed, precision and accuracy.
Once all the surveys and viability assessments had been completed, the actual engineering works commenced with our main contractor, BAM International. One of the main reasons for selecting BAM was their ability to use a large selection of specialist equipment which they directly owned and operated. This gave them flexibility to mobilise the equipment as necessary and adjust hire periods to suit the programme, which was important given both the tendency for unfavourable weather to occur and because of the tight timeline we had to complete the project.
The first phase of the project is the excavation of the seabed to create a foundation trench. A length of the new quay wall foundation trench will be excavated, along with a portion of the vessel turning circle, which requires the dredging of approximately 200,000 cubic meters of material from the sea floor. This will increase the eventual depth from 12.2 to 20.2 meters. Part of this phase involves the excavation of an even deeper trench to enable the laying of the foundation blocks for the base of the new quay wall. To ensure that the project proceeds at the required speed, it is crucial that the quay wall foundation blocks are ready to lay immediately upon completion of the excavation. This way, the massive task to produce the huge concrete blocks required for the project can commence in tandem with the excavation works. For the new quay wall blocks, RAK Ports did not have to look far to find a supplier capable of producing the blocks. Steven Rock is a company of over 40 years standing, which operates the limestone quarry directly adjacent to Saqr Port. The company, in conjunction with its sister brand RAK Nor, has the expertise to produce tailored, bulk concrete products for projects of any specification, even for a project as massive as this. Upon Steven Rock's appointment as the quay wall block supplier for the project, a dedicated casting yard was set up, which is a standalone facility capable of producing the concrete quay wall blocks required for the project. The casting yard facility is located in RAK Maritime City, a neighbouring free zone directly adjacent to Saqr Port, and also under the management of RAK Ports. The close proximity of the limestone quarry, which is the source of raw materials for the blocks, to the casting yard, which is in turn virtually next door to Saqr Port, makes for an extremely efficient process with regard to the production of the blocks and their transportation to the project site. The extreme external temperatures, which can reach well in excess of 40 degrees Celsius in the summer months, means that the typical method of concrete block manufacture, using metal molds and a traditional concrete mix, is not ideal. Other factors, such as the very large size of the blocks and the required speed of their manufacture, further complicate the casting process. Therefore, a tailored method, using a special concrete mix and wooden molds, is employed to cast the blocks required for the project. The casting process takes place during 4 p.m. and 11 p.m. each day, taking advantage of the lower evening temperatures, after which the blocks are given time to set in their molds and then removed to a curing area. This method, which is almost unprecedented for a project of this size, ensures that blocks are cast and matured in a way that gives them sufficient strength to withstand the massive forces they will ultimately have to cope with when the quay wall is complete.
The key criteria of setting up with the cast yard, it was driven predominantly by casting in high temperatures. We also specifically developed the mix design to cope with thermal differentials. The key challenge with the mix design was to maintain consistency, keep it as coarse as possible, keep its thermal characteristics as stable as possible. Very, very few people worldwide have done this in this way. And it's about the blend of expertise, knowledge, and experience of using maturity technology that has enabled that to take place.
Once the quay wall blocks have been cast, they need to be moved to the berth construction site, which, although less than 1 kilometre away, is separated from the casting yard by the open sea. Therefore, each of the quay wall blocks must be transported by barge to the construction site. This is achieved by continually ferrying blocks to a massive crane barge, which consists of a 400-ton crane supported by an 80-metre barge platform. The crane barge has been erected in the open sea directly in front of the intended location of the new quay wall, and will be the main piece of equipment used to place each of the blocks both under and above water. Its immense mechanical power, combined with a high degree of precision and accuracy, enables each of the blocks to be placed exactly in their intended position, to an order of millimetres.
In the construction phase, the technology used to place the blocks underwater by the contractor is of key importance. The design tolerances given are very tight for technical reasons. And the placement of those blocks underwater using the latest dive survey technologies by the contractor that we've built into the specifications have all come together with the right contractor and the right consultant to deliver the project.
Upon cutting of the trench, that then was allowed to bring in our own strategic plant, BAM International's plant, to physically place the foundation and prepare for the first block. That was mainly done with our IB 425 and 422 barges, where we use our own in-house designed screed frame, which is a hydraulic rectangular structure that sits on the seabed. It can grade material to within 10 millimeters of the requirements of the specification. So upon completion of the grading of the seabed, we are then in position to place our blocks.
The first quay wall block is placed on August 1st, 2017. Construction of the quay wall will continue for several months, with the casting yard ultimately producing over 5,000 blocks of an average weight of approximately 80 tons. Rapid and accurate laying of the quay wall blocks, which is tightly aligned with the process of dredging and land reclamation, creates significant efficiencies for the project. Time lost from weather events and other delays can be clawed back, facilitating the speed at which the project progresses and potentially enabling the works to be completed ahead of time. A continual support feature of the project is the use of experienced divers, who are essential in managing all marine activities. This includes ensuring the accurate placement of the foundation material and wall blocks, core rock backfill, armor rock and stabits. The underwater work is extremely high risk in nature, involving huge concrete blocks suspended by crane lines in close proximity to the divers. Therefore, having robust safety procedures in place is of paramount importance. The team has been specially selected from divers that have worked extensively in similar projects within the Middle East region, and all of them possess expert knowledge on diving health and safety in such conditions. As an extra measure, daily safety briefings take place before every dive for both the divers and crane operators. The team of project divers operate from the same dedicated crane barge which lifts and lowers the quay wall blocks into place. The variable sea swells and currents must be taken into account on a continual basis to assess the suitability of diving conditions. For this, the team use a special piece of equipment called a wave buoy, which records the weather data required to plan diving activity. Recording such data is crucial due to the variability of weather conditions at the project site. Unfavorable weather conditions are a constant risk to the project timeline. Large swells are common in this part of the Arabian Sea, and the exposed location has the potential to compromise various aspects of the works. Before the project even started, unfavorable weather was considered to be one of the major obstacles to the successful completion of the project, and the entire program revolved around identifying periods of benign weather and maximizing critical activities at these times. This included the factoring of weather downtime into the project planning.
Weather is probably the biggest variable element in this project, and that adds to risk. When we were assisting Saqr Port Authority selecting contractors, we placed a lot of emphasis on review of contractors' program and methodology to ensure that they'd accounted for suitable risk factors and methodology that would minimize risk throughout this construction duration. choosing BAM International was a positive move, and they'd put together a significant amount of energy and effort into their bid and their tender documents that showed that they had the risk fully under control during the construction process.
Incidents of unfavourable weather have indeed displaced filter rock placed on the existing breakwater. In late 2017, waves damaged the revetment under construction, which links the end of the existing breakwater to the new quay wall. However, a pre-planned decision by the project team to leave large 2 to 5 ton armour in situ on the existing breakwater minimised the potential damage. The decision to leave the armour in place bore testament to the proactive and detailed planning demonstrated throughout the project. A perfect example of how tight project management ensures that slippage is counted through measures to improve the overall speed and efficiency of the works. It is only via the application of advanced project management techniques that the team principals are not only able to cope with issues such as days lost due to bad weather, but can efficiently coordinate the many different processes, skills, equipment and stakeholders required for the smooth running of the project. The creation of the reclamation platform 130 metres wide between the new quay wall and existing breakwater, providing 85,000 square metres of land, requires the placing of approximately 1 million cubic metres of material, which will be dredged from the seabed. This phase of the project requires close cooperation between multiple project stakeholders and contractors, who are working to a deadline to complete and hand over the first berth in October 2018.
The dredging and reclamation activities posed a major risk to the overall project, both from a timing and cost perspective. There still remains some uncertainty on how easily the material would dredge, and we were concerned about whether the material would flow as predicted through the pipelines to the point of discharge. The reclamation process also had to be carefully monitored to control the amount of silt and fines that were deposited. If this process was not managed carefully, it could easily have led to performance issues in the reclamation platform and added additional cost through needing to implement ground improvement techniques.
The project delivery date means that the dredging and reclamation works need to be completed as quickly as possible, and the works are therefore divided into 3 phases. The first phase involves the removal and disposal of the top layer, consisting of silty surface deposits over the entire dredged area. This material is unsuitable for inclusion in the reclamation platform and is stored in a predetermined area away from the work site.
It's not possible for the engineers to guarantee exactly what the material properties will be of the reclamation after it's come out of the cutter suction dredger. So we produced a performance specification which allowed BAM the flexibility to undertake ground improvement if they needed it once the reclamation was in place to meet the criteria.
Once this layer is removed, the dredging of the quay wall trench starts, which in turn allows the construction of the new quay wall to begin. Upon commencement of the quay wall construction and placing of the rock wedge directly behind it, the second dredging campaign can begin with dredged material being pumped directly behind the new quay wall.
Once the wall was sufficiently constructed for us to remobilise the dredger and ultimately create some land for us to give Saqr Port the usable space behind the berth, the dredger was mobilised in January of 2018 for phase 2 dredging, where it dredged approximately 500,000 cubes and pumped it directly behind the wall.
Ordinarily, the entire length of the quay wall would be constructed and the dredged reclamation material would be pumped into the entire reclamation platform area. However, because the dredging proceeds at a faster rate than the quay wall construction, the full length of quay wall will not be constructed in time to allow the dredged reclamation material to be pumped directly into position. Without the new quay wall in place, the dredged reclamation material would flow into the trench of the quay wall that is still under construction and out into the vessel turning circle area. It is for this reason that a third dredging campaign is required to complete the reclamation platform once the remaining length of the new quay wall is constructed. The sheer volume of material that the dredging operation will displace means that the large-scale cutter suction dredging equipment is required to complete the job effectively and on time. Having experienced some productivity issues with the dredgers used at the beginning of this phase of the project, the team make the decision to scale up the operation by utilizing one of the world's largest cutter suction dredgers, the Athena. Built in 2011, the Athena is 130 meters in length and has been used on several major land reclamation and dredging projects all over the world. It is capable of dredging to a depth of over 30 meters and its specially designed cutter heads are suitable for dredging sand, silt, clay, gravel and rock. The Athena positions itself by using its large spud poles at the bow of the vessel and anchor poles at port and starboard sides. This enables it to dredge wide sections of seabed in a semicircular arc. The entire dredging and reclamation part of the project is critically dependent on precise timing and coordination. The first campaign needs to be completed before the closure of an advantageous weather window, which subsequently allows the first length of quay wall to be constructed. Failure to achieve this will have a catastrophic effect on the overall program and seriously impact the second and third campaigns, which would ultimately see the project fail to hit its delivery date deadline, with significant potential economic consequences for RAK Ports. However, the process of managing the work in separate campaigns, combined with the efficiency of the Athena, speeds up the overall progression of the project and ensures that the ambitious October 2018 delivery date will be met. By tailoring the quay wall construction methodology and optimizing project resources, the project has moved slightly ahead of its scheduled timeline upon reaching the next key phase, which is the construction of the final upper layer of the quay wall, known as the capping beam. The capping beam is the final stage of the actual quay wall construction. It is a 3 to 4 meter concrete cap which sits on top of the main structure. The addition of the capping beam will provide the final dimension of structural integrity required to give the quay wall its overall strength and ability to absorb the sea forces it will encounter. Contrasting with the considerable magnitude of this phase is the level of precision and detail required in terms of controlling the temperature of the concrete mix and the accuracy of beam casting and positioning. However, before the capping beam is laid, a process known as preloading must take place. The purpose of preloading is to eliminate residual settlement, ensuring that the foundation of the quay wall settles before the capping beam is laid, and to avoid any remaining settlement taking place when works are finally completed. Such a scenario could result in the structural integrity of the quay wall being compromised. This is a critical and highly sensitive activity, whereby a significant load is placed onto the top of the quay wall to simulate the weight of the actual capping beam when the berth is in operation. The load required to simulate this is calculated to be 60 tons per square meter. To achieve the required load, additional concrete quay wall blocks, weighing on average 80 tons each, are cast and stacked in a predetermined sequence, 3 blocks high along the front edge of the quay wall, and 5 blocks high on the rock fill directly behind the quay wall. The preloading blocks remain in place until a settlement rate of less than 2 mm in 24 hours is recorded, which takes an average of approximately 7 days to achieve.
The preloading was a mammoth task. It required inducing a load of 600 kPa into the foundation of the wall. To break the 600 kPa into more user-friendly numbers, it is approximately 210 tons per running meter of the wall. Once the preloading is completed, it is verified by ensuring there is no further settlement within the wall. So i.e. we've less than 2 mil settlement within 48 hours.
Upon successful completion of preloading, the construction of the capping beam can start. The vast size of capping beam required is influenced by a number of factors. These include the immense bulk of the Cape-sized ships that the berths are ultimately designed to accommodate, and the need to comply with international safety standards. Ensuring that the capping beam is delivered to its exact specifications is equally important from a commercial perspective as it is from an engineering perspective. With the annual cargo handling capacity of Saqr Port increasing by in excess of 30 million tons, the beam must be designed to adhere to maritime best practices with regard to ship berthing.
The capping beam would need to be larger than would normally be encountered in a sheltered or protected harbour, and it would need to be cast in situ, incorporating steel reinforcement so that it would form a monolithic structure. Only by building the capping beam in this way would it give the required strength to endure the forces to which it would be subjected.
The capping beam on this project is massive, and there's a couple of reasons behind that. Firstly, to meet the international factors of safety, it was required for the structural stability of this large quay wall. Secondly, the fenders on this project are equally large, based on the Cape-sized vessel that the client is hoping to accommodate on the berth. And thirdly, it allows in the future bunkering of the vessels which are moored alongside, meaning they can turn off their engines and use shoreside power, which is obviously a cleaner source.
The concrete used for the capping beam is a special, very high-quality mix suitable for use in marine environments. It has been formulated to comply with strict specifications with regard to temperature and other critical aspects. Due to the required specificity of the mix, it is regularly tested throughout the entire phase. Instead of casting the required blocks landside and lifting them into position, the capping beam is cast in situ on top of the precast mass concrete quay wall, with the beam being reinforced with a network of steel bars. Using this method of casting requires a high degree of precision. For this, a purpose-built formwork, known as the Traveller, was fabricated to support the works. The Traveller is a large-scale cantilevered mobile casting framework which traverses the top of the quay wall. Temporary rails allow it to move into the required position, and it is capable of retaining the poured concrete until cured. Casting the capping beam in this way ensures that the entire length of the beam is kept at the correct alignment, thus eliminating the need for large cranes to place precast molds.
We had to come up with a strategic plan that allowed us to cast this beam where we had up to 20% downtime as a result of the climatic conditions within the berth. The Traveller sits on a set of rails and is pulled by a winch into a position every day, and eliminates the requirement for shuttering at the front of the capping beam working over the sea. So the majority of the works are done from land. One of the other problems then with the capping beam was the management of the temperature within the concrete. So we had to ensure that at all stages that we did not exceed the requirements of the specification. We achieved approximately 40 metres per week with the Traveller, which is quite an achievement.
Using the Traveller system creates efficiencies for the project, as the Traveller can be set up quickly and stripped easily, while also providing safe access into the formwork to allow for the fixing of reinforcements and the placing and finishing of the concrete. By the time the final series of dredging campaigns have been completed, approximately 1.4 million cubic meters of material has been dredged from the sea bed, with 1 million cubic meters of this material being used to complete the land reclamation. Concurrently, the construction of the capping beam has been finalized and work has taken place to ensure that the capping beam and reclaimed land are aligned. These stages have all proceeded on schedule and the project is still on track to be delivered on time. The completion of the land reclamation and capping beam means that the project can proceed to the next and final major stage, the Landside works. The Landside works stage comprises of the integration and installation of essential berth infrastructure to facilitate what will ultimately be a large-scale commercial venture, operating 24/7. A variety of different systems such as power supplies, potable water pipes, berth lighting, telecommunications connections, pipelines and environmental protection equipment are all required to make sure that the berths will be fully capable of berthing, loading and facilitating the disembarkation of the world's largest cargo vessels. One of the first stages of the Landside works is the process of levelling the reclaimed land surface in preparation for the laying of interlocking paving. This involves the laying of an initial layer of concrete, which can only take place at night due to the high temperatures impeding the setting of the concrete. The intricate laying of the relatively small paving blocks over the large surface area of the reclamation platform is a process which requires significant manpower. Whilst the project has met all its deadlines to date, even at this late stage, the scale of tasks involved warrants careful management to make sure that the delivery date is not compromised. The fact that there are already a number of functional berths in the port means that learnings from how these berths operate can be applied to optimize the Landside works.
The paving was designed in coordination with Saqr Port operations, so we engaged with them at an early stage in the project and looked at their existing operations on berths 12 through to 5. We replicated what they found was useful, and then we made some improvements where possible. For example, they liked the flexible paving blocks, but on the corners they were struggling with the truck turning, plucking the blocks on the corners, so we designed some concrete solution there that should give greater durability.
Concurrent to the Landside works, the process to tie in with the key revetments at the north end of the berth can be completed, together with the placing of the remaining 15-ton concrete armour units. In total, approximately 1,100 of the strategically positioned armour units are required to protect the revetments, providing an additional barrier to further future-proof the entire structure. Entering October 2018, the coordinated efforts of over 4 years of conceptualization, planning, design and execution are approaching final fruition. In the early part of the month, the effort to finalize the Landside works and the revetment tie-in with the reclamation platform reaches its closing stages. It represents a significant achievement for the main stakeholders that all major streams of the project, including these final stages, have progressed smoothly and on time. The project has drawn upon expertise from global leaders in the field of berth construction and has been supported by a combination of advanced technology in tandem with a huge amount of mechanical and manpower resources. Innovative, and in some cases unique, processes and techniques have been successfully employed to tailor solutions to the many different tasks the project has presented, and the overall management of each stage has been executed to best international standards to ensure that the final structure will be of world-class quality. The on-schedule completion of these last stages means that the finishing line for the overall conclusion and handover of the project is now in sight. On the evening of October 10th, preparations begin for a notable event: the arrival of the first vessel at the newly constructed berth. This is the first time the new quay wall, with its supporting infrastructure and apparatus, has been tested in full operational mode with a real commercial vessel. Despite the berthing being a relatively straightforward process, the Landside team are on high alert to ensure that everything proceeds smoothly. The berthing of the vessel proceeds perfectly. Every aspect of the operation has gone to plan, and the new quay wall can now be considered fully operational for commercial business. The following morning, the new berth is officially opened by the Saqr Port management. The event is attended by the key project managers from the various stakeholders, along with a number of the hands-on project staff.
It's been a huge undertaking to get to this point, really. I think everyone's pulled together as a team, and only by pulling together as a team have we managed to deliver it on time.
It's a huge achievement, and it now represents the deepest berth in the Emirates. Saqr Port is likely to become a main hub in the region for the import, export and transshipment of bulk materials.
Absolutely key to the success has been Jacobs from a design and construction supervision point of view, and then BAM obviously who actually did the hard work of delivering the job on time. RAK North, Steven Rock have been absolutely fantastic in delivering both the interlock paving, the mass concrete blocks for the quay wall, the aggregate that goes in behind the quay wall, all of the other raw materials that's necessary to construct this facility.
It's an exposed berth, there's no breakwater around it, so we have to take extra precautions. To bring the ship in for the first time, it involved coming into a new channel, a new dredged area that had not been gone into before by a ship. The pilots did a great job. They brought the ship in as if they'd done it 1,000 times before.
What a lot of people don't see is when the height of summer, when we're at the most critical stages, you know, the guys that are working down the bottom of the formwork of the capping beam, the extreme temperatures to try and deliver this project on time. So I can't speak highly enough of all the team effort that was put forward.
The successful completion of this massive project, resulting in the opening of 2 new deep water berths capable of handling Cape-sized vessels, consolidates Saqr Port's position as one of the leading bulk handling ports in the entire Middle East region, and positions its home emirate of Ras Al Khaimah as one of the leading global hubs for the industrial and construction fields.
This project pushed the boundaries of mass concrete gravity quay wall construction and introduced a number of unique factors not commonly encountered on jobs of this nature. As it stands now though, through teamwork and a collaborative approach, we've successfully constructed one of the world's tallest mass concrete gravity quay walls in an exposed location capable of handling some of the world's biggest ships.
Today we're very proud. We have the ability to service Cape-sized vessels, and the deeper port will play a vital role to bring about the competitive advantage of Ras Al Khaimah in becoming the leading supplier for armored rock, for other building materials and for limestone.